In this problem, we'll use higher order derivatives to solve problems related to velocity and acceleration. Now, s of t is equal to t squared plus 2t. Here t is time and the position of an object. Its position depends on time, or in other words, the position is a function of time. Okay, so velocity is defined as, velocity v is defined as the rate of change of position with time. Okay, so what that means is ds by dt, we are differentiating the function s of t with respect to t, that is equal to 2t, because d by dt of t squared is 2t, d by dt of 2t is 2 times 1, which is 2. So ds by dt, which is the first derivative of the position function, is the velocity function. So the velocity depends on time again. The velocity specifically when the time is, let's say, 2 seconds. Okay, let's just say time t equals 2 seconds and we're trying to evaluate the velocity function at 2 seconds. Then that's equal to 2 times 2 plus 2, which is 2 times 2 is 4 plus 2 6. Assuming that this is in meters, assume that time is in seconds. The velocity at 2 seconds is 6 meters per second. So this is the unit of measurement for velocity, the rate of change of position with respect to time. So the time is in the denominator, the position is in the numerator. Next, acceleration is the rate of change of velocity with time. So we differentiate the velocity function, which is the same as differentiating the position function twice. And when we differentiate the right hand side, we get 2 times 1 plus 0. Now d by dt of v of t, which is the same as the second derivative of the function s of t. The first derivative of the function s of t, the position function, is velocity, and the second derivative is acceleration, and the acceleration is 2. The units of measurement of acceleration is meters per second square. So the unit of measurement of position or distance is in meters. The unit of measurement of velocity is in meters per second, and the unit of measurement of acceleration is meters per second square. And if we want to calculate the acceleration function, which is equal to 2, that is the acceleration. Now suppose the position function is s of t equals radical 2t squared plus 1. Remember that t is time, s of t is the position function. The velocity function is the first derivative with respect to t of the position function, which is equal to 1 over 2 radical 2t squared plus 1 times d by dt of the inner function, which is 2t squared plus 1. So that is equal to 1 over 2 radical 2t squared plus 1 times 2 times 2t plus 0. So we have 2 and 2 cancel, and that is equal to 2t divided by radical 2t squared plus 1. Suppose we had to find the velocity at exactly 3 seconds, then we just plug in 3 into the velocity function, so 2 times t becomes 2 times 3, divided by the square root of 2 times 3 squared plus 1, which is 6 over 3 3s are 9, 9 2s are 18 plus 1 19. And the unit of measurement of velocity is meters per second. Just like velocity is the rate of change of the position with respect to time, which means you take the first derivative of the position function to get the velocity function, and the velocity function is this. The rate of change of velocity with respect to time is acceleration, which means we get the acceleration by differentiating or finding the derivative of the velocity function with respect to time. So we take the derivative of the velocity function, which is equal to v of t 2t over square root of 2t squared plus 1. So we square the denominator times derivative of numerator minus numerator times derivative of denominator. So that is equal to square root of 2t squared plus 1 times 2 minus 2t times 1 over radical 2t squared plus 1 d by dt of the inner function, which is equal to 4t, the whole divided by 2t plus 2t squared plus 1. We simplify this expression, and that gives us the acceleration function. So once we differentiate the function, we get radical 2t squared plus 1 times d by dt of 2t is 2 minus 2t times d by dt of radical 2t squared plus 1 is 1 over 2 radical 2t squared plus 1 times the derivative of the inner function, which is equal to 4t. The whole divided by, when we square this, we get 2t squared plus 1. Simplifying, we get 2 radical 2t squared plus 1 minus the 2 and the 2 get cancelled, and we have 4t times t, which is 4t squared divided by radical 2t squared plus 1. The next step is taking a common denominator. So that is 2, and we multiply and divide with radical 2t squared plus 1, which is the common denominator, minus 4t squared. Simplifying, these two together, multiplied together, gives us 2t squared plus 1, because radical x times radical x is equal to x, minus 4t squared, the whole divided by, this goes to the denominator, and we get square root of 2t squared plus 1 times 2t squared plus 1. And this is the acceleration function. Now we can determine the acceleration at any point of time. So if we plug in t equals 3 seconds, we get the acceleration at specifically at t equals 3 seconds.